Dear aspirants, welcome to my channel. This is a model question paper 1, Concepts of Mechanical Engineering 2. Subject code is 25ME21I. So today we are going to learn 5 marks questions. So if you study, you will get 25 marks if you attend 5 questions for 5 marks. The first question, define following terms: coordination number, lattice point, packing factor. So what do you mean by coordination number? The number which is nearest to the neighboring atom, which is surrounded with a particular atom in a crystalline structure. That we call it as a coordination number. So you can give an example. We can give a cubic structure. Its a coordinate number is 6. So coming to the lattice point, it is a point, the position in a crystal lattice where when atom, ions or molecular located, it is representing repeating arrangement in the crystals. That is, we call it as an lattice point. And next is packing factor. Also we call it as an atomic packing factor. It is the ratio of volume occupied by atoms to the volume of unit cells. That we call it as an packing factor. Okay, this packing factor indicates how closely atoms are packed in a structure. Next question, explain laser surface treatment process. So before going to that, what do you mean by laser surface treatment process? It is a process when high energy of laser beams used to modify surface property of the material without affecting in a core material. So that will be top surface of the material. This process we are going to apply. How it will be worked? So for coming to the working, first what we have to do, focus laser beam is directly into the material. Next, surface layer rapidly heated, and first we have to heat, then you have to cool. Then this changes the microstructure, improve the property. First we have to heat, then you will get the, if you get the cool, the change the micro structure will be changed and property going to change and property going to increase. So what is the advantage or purpose? What is an advantage if you do that? So you can increase the surface hardness and improve the wear and corrosion resistance and produce minimal deterioration and precious and localized treatment. And you can, what is an application? So where we have to use? We can use it for gears, tools and engine parts and improve the life of machine components. Okay, this laser treatment enhance surface strength, durability while keeping inner material unchanged. Next is water shape memory alloy, that we call it as an SMAS. Explain their unique property and mention 2 applications where SMA are used. So before going to, we should know what do you mean by shape memory alloy, SMA. It is a special type of material or metal that can return its original shape after deforming when exposed to suitable temperature. So if you take out deform, so when if you expose to temperature, then you can return to same original shape of the material. And unique property or shape memory effect, how it will be. So when you when an SMA is deformed with a lowest temperature, it can recover its original shape upon heating. So what happened then, due to reversible change in a crystal structure, the phase deformation will be takes place. So coming to the application. So application, we can use it for medical field and we can use it for accumulators. So in the medical field, you can use it for sentence and orthodontics wires. Okay, actuator used a device which required control moments, and we can use like valves and switches. There we can use. So coming to these materials, it's a smart materials, ability to remember and regain their shape, making them useful for advanced engineering and medical property. It's having a regain shape, original shape. That's why they're going to use. Next is identify and explain the appropriate surface hardening process for the stainless steel used in various industrial applications. So here we can suitable process which we can use it for stainless steel, which is low temper low temperature nitriding or plasma or gas nitriding. These suitable for the stainless. The following the reasons for selecting: one is a stainless steel contains chromium which provide a corrosion resistance, and high temperature process it like carbonizing from chromium carbides and reducing the corrosion resistance, and low temperature nitriding avoid these problems. So the process is first what we have to do: steel heated about 400 to 500 degrees Celsius, and then we have exposed nitrogenous rich environmental ammonia gases as plasma formation, and nitrogen diffused into the surface and form exposed authenticated layer of the S shape, and this layer increasing hardness without damaging the chromium layer. And advantages we can use it for high surface hardness, improve the wear and fatigue resistance, maintain corrosion resistance, and which we can use it for low deteriorations due to a low temperature. Coming to the application, which we can use it for valve shafts, surgical instrument, and food processing equipments and industrial components. And it is having a low nitriding. It's a best surface hardening method for stainless steels, as provides hard durable surface, will preserve corrosion resistance, which essential for the industrial use. Next, highlight the different additive manufacturing technologies. There's a additive manufacture 3D printing, okay, building object layer by layer, different methods. So the main type is fusion deposition modeling, FDM. So what we have to do, we have to use a melting plastic filament to build parts layer by layer, and it is low cost and widely we can used. And next method is stereolithography, so which we can use it for liquid resins curves by the UV light and give high accuracy and smooth surface. Next is selective laser sintering, that we call it as an SLS, which we can use it for laser fuse powder material. It is very strong and complex parts. Next is binder jetting. It's a spray binders on a powder from layer used for metals and sand casting. And next will be a directed energy deposition, DED. This is a melt material used for using a layer while depositing and used a repair and large components. Next is mention the application of rolling process for metal forming. First one is a production sheets and plates, so which we can use it for manufacturing metal sheets, strips and plates, various industries. Next we can use it for structural sections. It is production of I-beams, channels, angles, rails, use it for construction. Next we can use it for railway track. We can use for railways, okay, railway rails. And we can use it for bore rods, bars and wires for engineering applications, which we can use it for automobiles, okay, ship buildings. So use it for making body panels, frames and structural components. Next, explain any two components of press. One is a frame, okay, it is a main body of the press machine, support all other components. And next, it withstand and absorb forces during operation, and it provide rigid and stability. Next one is an ram or slide. It is a moving part of the press, moving up and down, applying force on workpiece, and hold upper die and perform pressing operation. This frame provides support, while ram performing actual pressing work in a press machine. Next is classify cutting tools. So cutting tools we can classify different factors. One is based on number of cutting edge. There is a first one is a single point cutting tool. It is having a one cut edge. We can lathe machine, we can give an example. So multiple point cutting tool, it is having a more than one cutting edge, that we can give as a drill and milling cutter. Next is based on tool materials. It is again high speed steel tools, carbide tool, ceramic tool and diamond tool. And based on the operation, one is a turning tool, drilling tool, milling tool and grinding tool. See, if the content is useful, please subscribe my channel, share and support. And PDF link also I am going to put on bio. Okay, thank you. Okay, please subscribe my channel, share and support. Thank you.